So we're going to start to look at a different way to work with trig, and that's with identities and simplification. So first off, a trig identity is a trig equation that is always true no matter the value of the variable. Identities that equal each other can be substituted for each other in a variety of different problems. You already know the trig identities below. So secant theta is always equal to 1 over cosine theta. Cosecant theta is always equal to 1 over sine theta. And cotangent theta is always equal to 1 over tangent theta. So the idea is when you have an identity, these two are interchangeable. Okay, so if I have secant theta, I could plug in 1 over cosine theta or vice versa. Now over here we have our quotient identities. We know that tangent of theta is equal to sine theta over cosine theta. And cotangent theta, because it is the reciprocal of tangent theta, is equal to cosine theta over sine theta. So these are also interchangeable. Cotangent theta with cosine theta over sine theta, for example. So in our first simplification problems, we're going to be following a couple different hints. Basically, we have these different problems to simplify, and we're just trying to sometimes write them as a single trig function or just a more simplified form. So first off, it usually helps to write everything in terms of sine theta and cosine theta. We're going to use the quotient identity for cotangent theta, not the reciprocal identity, because the quotient identity allows me to write it in terms of sine and cosine, whereas the quotient identity does not, or reciprocal identity does not necessarily do that. Now, not as much with this set of questions, but when we get to the harder ones in the last lesson, you do have to be creative and persistent. If the first thing you try doesn't work, try a different substitution, and then the more you do them, the more you get an idea of what will help you. So in the first one, we have cosine of theta times tangent of theta. So what I can do is I can plug in sine theta over cosine theta for tangent. Okay. And I'm just going to rewrite cosine theta in the front. Now, I'm going to write cosine theta over 1 because that helps when I'm multiplying. And we know we multiplied the numerators and denominators, but we can also cancel anything from the numerator to the denominator before we multiply. So the cosine thetas cancel, and this is just sine theta, which is my single trig function. Looking at the next one, same idea, except now we have division. So for cotangent theta, I'm going to use the quotient identity cosine, and this is, sorry about that, cotangent y. So this is cosine y over sine y. And then for cosecant, I'm going to use 1 over sine y, because that's equal to cosecant of y. So because I have a complex fraction, I'm going to keep my first fraction, change to multiplication, and flip the second fraction. So this is sine y over 1. So this time the sine y's cancel, and I'm just left with cosine of y. Now, as you start to get used to these, you can definitely try some on your own. I'm going to scroll down a little bit, but I will continue doing them, pause the video to try them when you get a chance. So looking at this one, secant theta is 1 over cosine theta, and cosecant theta is 1 over sine theta. So we're going to do that keep, change, flip. Change this to multiplication, and then sine theta over 1. So nothing cancels here. So if I multiply across, I get sine theta over cosine theta. So we're still not at a single trig function, but working backwards, I know sine theta over cosine theta equals tangent of theta. So now I've simplified that down to a single trig function. So make sure you have that down. I'm going to erase it to do letter D though. So looking at letter D, I'm just going to write the answer here. So in case you're forwarding, you know that that's the final answer on that one. So in this one, we're proving something, which basically means that I simplify both sides until they become the same thing. But I can't divide on both sides or do any sort of solving processes because then other things come up that won't be a perfect proof. So tangent theta is sine theta over cosine theta. Cosecant theta is 1 over sine theta. And then over here on the other side, secant theta is 1 over cosine theta. So looking here, my sines cancel, and I have 1 over cosine theta equals 1 over cosine theta. That's when we've done the proof, when they're both the same on each side. Now I could rewrite secant theta equals secant theta there, but as soon as they both become the same thing, that's enough for the proof. So in letter E, we see our first time where we have adding. Now, first I'm going to plug in using the reciprocal functions. So secant theta is 1 over cosine theta, and cosecant theta is 1 over sine of theta. Now to add, we need an LCD. So looking at these, the theta is part of the cosine and the sine. So it's not like I need a cosine, a sine, and a theta. I need cosine theta. Okay, that's one thing, and sine theta. So it's not multiplication, it's not sine times theta, cosine times theta. So my LCD is cosine theta and sine theta. My first fraction is missing the sine theta. So I'm multiplying by sine theta over itself, and my second fraction is missing the cosine theta. Okay. Now, we're going to have a common denominator of sine theta, cosine theta. So I'm actually going to do the adding as I write that. In my numerator, I'm adding sine theta plus cosine theta. So in the other problems that we've had to simplify versus proving, we've had to write it as a single trig function. This one does not say that. It actually looks a little more complicated than what I started with, but that is simplified because I've added the two fractions together. So here's another proof problem. I have sine theta times cosecant theta minus 1 equals tangent theta times cotangent theta minus cosine theta. So here, I'm going to rewrite cosecant theta as 1 over sine theta so that I'm ready for my multiplication step next. And then I'm going to use my quotient identities for tangent and cotangent, and I'll move on from there. So sine theta over cosine theta times cosine theta over sine theta minus cosine theta, and we'll put this over 1. I'm also going to put this over 1. So when I distribute, here in this distribution, the signs cancel, so I just have 1. In the second distribution, I have 1 times sine theta, or negative 1 times sine theta, so I get 1 minus sine theta as the final answer on that side. So now I'm going to distribute. In my first two fractions, both sine and theta will cancel. Sine theta and cosine theta will cancel. Sorry about that. And then in my second distribution, just the cosines will cancel. So I have sine theta. So there's my proof. Both sides are the same thing. So we have one more adding one, and then something where we start to have some squareds in here. So simplify this expression, leave your answer in terms of sine theta and cosine theta. This one actually ends up being easier, we're going to see. Cosecant theta is 1 over sine theta. Cotangent theta is cosine theta over sine theta. So we already have a common denominator. So adding the numerators, I have 1 plus cosine theta, and that's over sine theta. In my second problem, so here, just like secant theta is 1 over cosine theta, secant squared theta is 1 over cosine squared theta. And remember from our work with the quadratic trig functions, we write the squared in between the angle and the trig function. So cotangent theta is cosine squared theta over sine squared theta. And then sine theta is just sine theta over 1. So these kind of obviously cancel. When I get to sine theta and sine squared theta, I'm going to rewrite it like this. So I'm going to pretend the sine squared is an x squared and the sine is just an x. So if I was multiplying here, this x would cancel and I'd have 1x left down here. So the sine and the sine squared work the same way. So this completely cancels. And I just have 1 sine theta because sine theta times sine theta, the other sine theta canceled. So that's what I have here. So numerators, I just have a 1. Denominator, I have sine theta. And then to simplify this down to just a single trig function, that would be cosecant theta. That's my final answer on that one. Sorry, a little smashed, but you get the idea. So on the next page, we're going to start to look at the Pythagorean identity, but that's your basic reciprocal and quotients over here.